Welcome back to Exponential Functions Part 2. We're going to quickly go through the parameter changes, and then we're going to talk about end behavior and whether or not the function is increasing or decreasing. So first of all, the parameter changes. We have our a value, which is the number in front of the base. Tells us if there's a vertical stretch or compression. Then we have our base, which identifies the parent function. In this case, it's 3 to the x. And then we have our horizontal translation, which is always the opposite. And then we have our vertical translation, which is up and down. Okay, so in this case, we have a vertical compression of 1/2. So the graph appears wider. And then we have a horizontal translation of 2 to the right and 1 unit down. Okay? So we're going to look at end behavior real quick. So if you'll recall the parent function here, y equals 3 to the x, okay? Notice that on the left side, that would be, we're talking about end behavior here. So as x approaches, we're going to the left, so as x approaches negative infinity, f of x, which is your y, is approaching your asymptote, which in this case is 0. And going on the right side, as x approaches positive infinity, because we're going to the right, y, the arrow is pointing up, so f of x is approaching positive infinity. Okay, so a little bit different here because we have an asymptote here that's preventing this graph to go any lower than this line here. So let's take a look at this problem. So here we have a horizontal asymptote of y equals -1. So at -1, we have a horizontal asymptote. Okay, and again, this is going to be, our parent function is going to be 3 to the x. So this is going to kind of, when you graph it, it's going to kind of look like, let's see. Something like that. So if you're doing end behavior here, as x approaches negative infinity on the left, f of x is approaching our horizontal asymptote, which is -1. And on the right side, as x approaches positive infinity, because we're going to the right, f of x is approaching positive infinity. Now, when you read a graph from left to right, this graph would be increasing. The graph would be increasing. Now, could it ever be decreasing? Well, let's take a look at an example where it's decreasing. So this is an example of a decreasing exponential function. Okay, so let's take a look at what this looks like. Go ahead and make a table over here. Plug in some values and plot the points. So 1/2 to the -2 power. Okay? So a real simple way to make this into a positive 2 is to flip this. So this would be 2 over 1, or 2 to the second power, which is 4. Okay? So 1/2 to the negative 1 power. Flipping it over, we get 2 to the first power. Okay, 1/2 to the 0 power, which we all know is 1. 1/2 to the first power, which is 1/2. And 1/2 to the second power, which would be 1 squared, which is 1, and 2 squared, which is 4. Okay, plotting these points, we've got -2, 4. We have -1, 2. We have 0, 1. Notice it goes through 0, 1 because this is a parent function. It has no parameter changes. Okay, as a base of 1/2. 1/2 to a 4th. So here is an example of a decreasing function. Now notice, what makes this a decreasing function? Can you tell by looking at the equation? Versus an increasing function. Can you tell by looking at the equation? Can you tell what's different? And don't think parameter changes. Think about the base. Now let's write the end behavior for this. So going to the left, as x approaches -infinity on the left, so if we're going left, y is approaching +infinity because we're going up infinitely. On the right side, as x approaches +infinity, on the right, f of x is approaching our horizontal asymptote, which I haven't written in here yet. The k value is 0, so our horizontal asymptote, and yes, you must draw these in using dashed lines, please. And so this is approaching 0. Okay, well, I'll see you in class tomorrow, and we'll practice graphing these, writing end behavior, and determining whether or not the function is increasing or decreasing. Hope you're having a good night.